any subset of a sample space is called event. Okay, any subset of a sample space is called event. So for example, if we throw two coins and we are getting these head, tail, tail head, and tail tail. Okay, if we throw two coins and we are getting this. Now suppose if we need two heads, we will define an event two heads. Okay, we will define an event E which says two heads. So we can say E is equal to what? H and H. Okay, so this is a sample space. You already know that what is a sample space. Now, if we have an event which says that we need two heads, then we can form a set of event E, which is HH. So this is called the event. Or for example, if we are taking E1 is this, and E2 we say E2 is two tails. So what we get E2? E2 is equal to T and T. So what is this event? This is a subset of the sample space. This is a sample space and event is a subset of that. Krishna, this is clear?
Yes, sir.
Okay. So please note down this, confirming, then we will start the next one. Yusra, my voice is audible. Yusra, my voice is audible.
Yes, sir.
Okay, so Yusra, you have done the homework.
Sir, I've done the assignments.
Assignments of 3D.
Yes.
Okay, then did you start it probability?
Done, sir.
Okay, Krishna, very good. Yusra, you started the probability?
Yes, sir, I started the probability.
Very good. So any doubt in last topic?
No, sir.
Okay, very good. So Yusra, we have started the events. Okay. So what is the event? We have already done the sample space. For example, if we throw a coin, then the outcomes will be this one. If we throw two coins, okay. If we throw two coins, then the outcome will be head, tail, head, and tail. Hotvika, please reply me on the chat box if my voice is audible. We have started the events in the probability. Okay, so please check this. Suppose we throw two coins, then what is the sample space? HH, HP, TH, and TT. Okay. So this is the complete sample space. Now, if I will say that we need two heads, suppose we form an event even, and we say two heads, then what will be that event? That is H and H. So what basically is the event? Event is a subset of a sample space. You can see this is the subset of sample space. For example, if you will say two tails, then TT, then you can check this is the subset of sample space. So what is the event? Event is a subset of sample space. So they can define anything. They can say one head, E3, they can say one head and one tail. One head and one tail. Hotvika, no issue. One head and one tail. Okay. So E3 we will get head tail head. Okay. This is E3. You can see that this is the subset of the sample space. So Yusra, Utvika, this is clear? Utvika and Yusra? Okay, Utvika. Yusra, this is clear?
Yes, sir.
Okay, very good. Then please note down this, confirm me, then we will start the next one. Okay, Utvika, very good. Yusra, please note down this and confirm me, then we will start the next one. Yeah, I hope everyone has done this. So we will start the next topic. Yusra, please let me know if you have not noted this. Okay. Next is types of events. Okay. Now the first is impossible, impossible, impossible and sure event. Impossible and sure event. Okay. So what is impossible event? The set, the empty set. Okay. The empty set, this one, this is called impossible event. It's called impossible event. Okay, impossible means which never occur. So for example, getting a 7 in a throw of dice. Okay, so if we are throwing a dice and we are expecting that we will get a 7, then that is not possible if in the die the numbers are from 1 to 6. Okay, so what is an impossible event? Which never occur. So the empty set is called the impossible event. You can take any of the example which never can occur. Okay, next is sure event. So sure event, what is a sure event? The complete sample space, the complete sample space, the complete sample space is called sure event. Okay, it's called sure event. Sure event means that will always occur. So for example, if we throw a coin, suppose if we throw a coin head, we will get head or tail. Then which is the outcome which always occur? We can't say that head will always occur. We can't say the tail will always occur. But if we will take head and tail both, if we will take the event as head and tail, then there can be a possibility you will get a head or you can get a tail. That's why the complete sample space is called the sure event, because only the complete sample space there is 100% possibility that the outcomes will be from the sample space. So what is the sure event? Impossible and sure event. So the complete sample space is called the sure event, and the empty set is called the impossible. Impossible, which never can occur, and which always occur is the sample space. So any doubt in this, Yusra, Rishan, Krishna, Utvika?
Sir, I have a doubt, sir.
Right?
Can only the element H be sure event?
No. If you're tossing a coin, then suppose if you form this event, head. So this is not a sure event because every time we are not sure that we will get a head. Sometimes we can get a tail. So we will not receive this one. That's why this is not a sure event. But if we will take this one, complete sample space, sometimes we will get a head, sometimes we will get a tail. Okay.
Yes, sir.
Now, similarly, if we throw a dice, then what is the sample space? 1, 2, 3, 4, 5, 6. Okay. So this complete is a sure event because you will get any of these numbers. That's why there's a sure event. Okay. So please note down this and confirm me once this is done, then we will start the next one. Okay, Rishan, I've just checked you have joined recently. So you have missed some topic. We will again discuss that. First topic, Rishan, which we were doing. Rishan, I'm just changing the slide. So please take a screenshot and confirm me. We have just started the sequence. Okay, Rishan, please take a screenshot of this. And I will explain you what is the event. Event is the subset of a sample space. Okay, so for example, if we have this sample space, head, head, tail, head, tail, and in this we form an event and we say that even is two heads. Then what is the outcome? Even is HH. So this is the subset of the sample space. That's why the definition of event is subset of sample space is called the event. Okay, so Rishan, please reply me so that we can start the next one. Okay, please take a screenshot of this or you can note on this. Okay, Rishan, please let me know once this is done. I hope, Rishan, you have done this. Then please start, Rishan, this one, types of event. Okay. Okay, hope, Rishan, you have done this. So we have a types of event. The first is impossible and sure event. So what is an impossible event? The empty set. Empty set is called impossible, which never can occur. Okay, impossible events means which never can occur. So for example, getting a 7 and throw of die. Next topic, we have a sure event. Sure event which always occur. So which event can always occur? The complete sample space. Okay, Rishan. So for example, if we throw a coin and we are getting head and tail, then which event can always occur? The sample space, because we can get a head or tail. Okay, so sure events means sample space, and impossible is empty set, which never can occur. Next, second, we will take a simple event. Simple events. These are very simple definitions. Simple events is what? In an event, in an event, in an event, E, I'm sorry. If an event E has only one sample point, has only one sample point, has only one sample point of a sample space it is called a simple simple or elementary event. Okay, so what is a simple event which have only a single outcome? In simple words, we will say that what is a simple event which have only a single outcome. So for example, if we are throwing two coins, and we are getting this sample space, HH, HT, HT or TT. We have this sample space. Then what can be the simple event if we will say E1 is equal to 2 hits? If we will define E1 as 2 hits, then this is called a simple event because it has only a single outcome. Or we can say E2, this is equal to tail. This is also a simple event. Now, Krishna, can you tell me that E3, suppose we are getting head and tail head and this one. So is this a simple event, Krishna?
No, sir, because it has two sample points.
Yes, because it has two sample points, two outcomes. That's why this is not a simple event. So what is a simple event? Which have only a one sample point. Okay. So Rishan, Hotvika, Krishna, and Yusra, this is clear?
Yes, sir.
Okay, very good. Yusra, Hotvika, and Rishan, please reply me on the chat board and note down this and confirm me, then we will start the next one. Okay, Hotvika, you got your answer. Please complete this and confirm me.
Done, sir.
Okay, Krishna, very good. Hotvika, this is done. Rishan, Yusra, this is done. Okay. Yusra and Rishan, please confirm.
Yes, sir. Done.
Okay. Rishan, I hope you have done this. So we will start the next one. Third is compound event. Compound event. Okay. So what is a compound event? If an event has more than one outcome. If an event has more than one sample point. More than one sample point. It is called a compound event. It is called a compound event. Okay. So what is a compound event which have more than one outcome? For example, if we throw two coins, we have this outcome. Okay, TH and TT. Now, if we will say E1, getting one head and one tail. One head and one tail. So we can say E1 is equal to what? Head tail and tail head. So this event have two outcomes. That's why this is called a compound event. Okay. So what is a simple event which have only a single outcome? What is a compound event which have two outcomes? So there's a very simple definition. Please note down this, confirm me, then we will do the next.
Done, sir.
Okay, Krishna, very good. Yusra, Rishan, and Hudvika, please confirm me. Okay.
Done, sir.
Okay. Okay, Rishan, this time. Rishan, I hope you have completed this. Okay. So we will start the next topic. Now next is algebra of events. Algebra, algebra of events. So in sets, we have done some operations. The same will be done over here. Algebra of events, first is complementary event. Complementary, complementary event. Okay. So this is every for every event A, for every event A, there correspond there there correspond another event, this one. Okay, this is the sign of complement. For every event A, there correspond another event, this A naught. Okay, called the complementary called the complementary called the complementary event to A. Okay, it is also called it is also called the event not A. Okay, so what is the complementary event? Not A. So, for example, if we throw a coin, or sorry, if we throw a die and we are getting this number 1, 2, 3, 4, 5, 6, and I will say to you that A means A is even numbers, even numbers. Then what is A complement? Not even. Not even means which is not even. So if 2, 4, 6 we are getting, then A complement will give us 1, 3, and 5. Okay, so complementary means not. So if you have one event, you need to find the complementary of that. So what you need to do? Just find the opposite of that. So if they are saying the even number and they're saying A naught, then select the remaining of the numbers. Okay. So I hope no doubt in complementary events. Please note down this. Then we will start the next one. Okay, and we can this example, and we can define a complement like this. A complement is equal to X. What is X? X belongs to S and X do not belongs to A. So that means S minus A. Okay, so here we can define this complementary event in set builder form. That what is a complementary event? This is X. What is X? This belongs to sample space, and this does not belongs to A. As we have seen in this example, A was an even number. Then when we need to find the complementary of that, so what we have done, we have removed this A from the sample space. Okay, please note down this, confirm me, then we will start the next one. Okay, Osvika, I got your message. Yusra, Rishi, Krishna, and Ishan, please confirm once.
Done, sir.
Okay.
Done, sir.
Okay. Rishan, please confirm. So we will take example. Okay, we'll take a question and please try to do this. So the question is, consider the experiment Please try the fourth part. Okay. First, second, and third we will do later on. Please try the fourth one. The question is, consider the experiment of rolling a die. Let A be the event getting a prime number, B be the event getting an odd number. You need to find not A. So first of all, we need to find A. So anyone can tell me what is A?
So A is a set of prime numbers, that is
Okay, so can you tell? Okay, but before that, tell me the complete sample space. You are rolling a die. So what is a complete sample space?
is a 1, 2, 3, 4, and 5, 6.
2, 3, 4, 5, 6. Very good. Okay. Next, tell me what is A.
So A is 2, 3, and 5.
2, 3, and 5. Very good. Now find A naught. This simple. Can you tell me the answer?
It's a 1, 4,
1,
and 6.
1, 4, and 6. Very good. Okay. Yusra, Utvika, and Ishan, this clear?
Yes, sir.
Okay. Okay. Very good, Utvika. So please note on this and leave some space. We will do first, second, and third part after these topics. Okay. Please confirm me once this is done. Okay,
Answer.
Ulrika, very good. Okay. Rishan, please confirm me. So if you have any doubt, then we will start the next topic. Next is the event. Now, these topics are similar or exactly the same which we have done in sets. Okay, so the next is the event A or B. The event A or B. Okay, so what does that means? In sets, you have already done the union. So the same thing is over here. When they say when the sets just like this, A or B. A or B means event A or B. This is equal to A union B. Okay, event A or B means A union B. And what is this A union B? This means X belongs to A or X belongs to B. For example, if we have two events, let A be 1, 2, 4, and next is suppose B is 2, 3, 4. Next is 2, 3, 4. So what is A union B? So how we find A union B in sets? First of all, write the common values. So 2 is common, so write 2 single time. Then write 2 and 4. Okay, then write the remaining values 1 and 3. So how you find A union B? First of all, you will write the common value single time, then you write the remaining values. Okay, so this is A union B. I hope this is clear. So please note down this and complete the previous question. Tell me the answer of the previous question. This done. Then please share the answer of this question. You need to complete the first part, A union B. Okay, so Yusra get the answer. Yusra, good, this is correct. Krishna, this is correct. Very good. Potvika, please share your answer. Udpika, if this is done, the last question, then please share the answer. Udpika, I hope you have completed this. Okay, so we will start the next one. Third is A and B. The event A and B. Same as you have done in sets, the event A and B. Okay, so what does this mean? Event A and B is equal to, we represent this by intersection sign. And what is this? The intersection B, this is what? This means X belongs to A and X belongs to B. Okay. So A intersection means the common part, which belongs to both A and B. So for example, if you will take this question, A is this, then what is A and B is, the common part is 2, 4. So in this case, the common part, the intersection, the event A and B will be 2, 4. Okay, so this is a very simple topic. Please note on this and complete the previous question and share your answer. Please do the second part of the previous question. Krishna, very good. That is correct. Yusra, please share your answer. Yusra and Hotvika, please. Okay, Yusra, very good. Hotvika, very good. Okay. Now the next topic, fourth is the event A but not B. The event A but not B. Okay, so what does that mean? A except B. So this is A intersection B not. So what you will do in A but not B, you will remove the values from A which are there in B. So for example, if we have A is equal to 1, 2, 3, example, and we have B is supposed to 3. We need to find A but not B. A but not B. So this will equal to what? A minus B. So then that means this is okay. Yusra, Krishna, Hotika, I hope this is clear. So please complete the third part of the previous question. Krishna, very good. This is correct. Yusra and Hotvika, please share your answer. Okay, Yusra, good. Hotvika, what is the answer of this? Okay, Hotvika, very good. So I hope this topic is clear to all of you. We will start the next one. The next is mutually exclusive events. Mutually exclusive events. Okay, two events are said to be two events are said to be mutually exclusive, if if they can't occur simultaneously. If they can't occur simultaneously. Okay, they can't occur simultaneously. That means that is A intersection B is equal to null set. It's mean both are disjoint sets. Okay, or we can say two events are said to be mutually exclusive if there is nothing common in between two. So for example, if you are throwing a die, we are getting 1, 3, 5, and in this second event is suppose 2, 4, and 6. So these two are mutually exclusive because there is nothing common between two. Okay, so two events are said to be mutually exclusive if they are disjoint sets or nothing is common or they can't occur simultaneously. So please note down this, then we will do the next topic. Okay, and write a note. Simple events of a sample space, simple events of a sample space are always mutually exclusive. Are always mutually exclusive. Okay, please note down this. Confirm me, then we will start the next topic. Please confirm me once this is done so that we can start the next topic.
Done, sir.
Okay, very good.
Done, sir.
Okay, Hotvika, I got your answer. Now, this is mutually exclusive. Next is exhaustive. Exhaustive events. Okay. So what is exhaustive events? Events are said to be exhaustive. Events are said to be exhaustive if their union is sample space. Okay. Let A, B, C, let A, B, and C be three events. And A union B union C is equal to sample space. Then A, B, C and A, B, and C are called exhaustive events. Okay, so what are exhaustive events? Events are said to be exhaustive if their union is sample space. So if you find the union of any of the events and you're getting a sample space, then you will say that these are the exhaustive events. Okay, please note down this, or if you have any doubt, then please let me know. Otherwise, please note this.
So, do union of simple events is a sample space, sir?
Your question is the union of simple events is a sample space.
Yes, sir.
That depends. If you're taking all the simple events of a sample space, then that will give you. Yeah, for example, suppose we throw a coin, head, tail, tail, head, and tail, tail. So what is a simple event? Each outcome. One outcome is called. So if you take all these, and you find the union, then you will get a sample space. But if you select only 3, then you will not get a sample space. I guess your question is that all the simple events, if you take them, they are exhaustive events or not?
Yes, sir. Like they are equal to exhaustive events, right? In that case.
We will say that they are exhaustive if the union will give us a sample space. So that depends. If we will take all the outcomes, then definitely they are exhaustive events. If we miss any of the outcome, then it will be not.
Okay, sir.
Okay, that
Thanks.
depends. You're welcome. Okay, so I hope everyone has written this. Okay.
So just a second.
Okay.
Done, sir.
Okay. Krishna, this time?
Yes, it's done. Yes,
Okay.
it's done.
Okay. Next is exhaustive. Okay. So what are next topic is mutually exclusive and mutually exclusive and exhaustive events and exhaustive events. Okay. So what are mutually exclusive and exhaustive events? Which are both, which are mutually exclusive as well as exhaustive. Mutually exclusive means nothing is common between two, and exhaustive means the union will give the sample space. So the event. Okay, so that means there is nothing common, as well as the union will give us a the union will give us a sample space. So for example, we have events, and when we find the intersection of these two, this is null set. And when we find the union of these two, this will give us a sample space. Okay.
Yes.
Please note down this. And all the topics are completed. Now we will try the questions. Okay. Please confirm me once this is done, then we will start the questions.
Done, sir.
Okay. Okay. Yusra and Hotvika, this done. Okay. Yusra, this done.
Sir, can you please explain exhaustive events once more?
Yeah. Exhaustive means if you find the union, then it should give you the sample space. So for example, if we throw a die and we get these outcomes 1, 2, 3, 4, 5, 6. 1, 2, 3. Say the B is 3, 4, 5, 6. Then Yusra, what is the union of these two events? Yusra, what is the union of these two events? Yusra, my voice is audible.
Sir, the union will be 3, 1, 2, 4, 5, 6.
Yeah, that means 1, 2, 3, 5, 6. We can say that is the sample space.
Yes, sir.
Okay, so that's why these are exhaustive events. So the events whose union will give you the sample space is called exhaustive. Please try this. So you need to tell that which pairs of these events are mutually exclusive, are mutually exclusive. Okay. The two dice are thrown. Some of the numbers which come on the two dice is noted. The event is the sum is even, sum is a multiple of 3, sum is less than 4, and the sum is greater than 11. You need to tell that which of these events are mutually exclusive. So, but before that, tell me the sample space. What is the sample space of this?
So sample space of two dice rolled.
Yes, two dice roll.
So it's 1 comma 6 and then until 6 comma 6.
Okay, so total outcomes will be
36.
36. Very good. So your first element will be 1 comma 1, next is 1 comma 2, next is 1 comma 3, and so on up to 6 comma 6. So total outcomes will be 36. Okay. Now sum is even. A is sum is even. So what are the outcomes? 1 comma 1, then 1 comma 3, then 1 comma 5, then 2 comma 2, next 2 comma 4, next 2 comma 6, next 3 comma 1, 3 comma 3, 3, uh, next 4, we can't take 4, we can take 5, we can't take 6. Similarly 4, then we can't take 1, we can take 2, 4, next we can't take 3, we can take 4, next is 4 comma 6, next is 5. Okay, so next is 5 comma 1, 5 comma 3, and 5 comma 5. Last I will write over here. We'll take 6, so 6 comma 2, 6 comma 4, 6 comma 6. Okay, so these are the outcomes. Now please solve this. Now similarly, please find the B, next find C, and then find D, then decide that which of the pairs are mutually exclusive. Please do your answer once this is done. Hotvika, okay. No, you don't need to find the sum. Okay. So this is the event A. This is the event A because the event A is the sum is the event. Similarly, you need to find the event B. The sum is a multiple of 3. Similarly, you need to find the event C. The sum is less than 4. You need to find D. The sum is greater than 11. When you find all these events, then you need to check which are mutually exclusive. That means which have nothing common. If anyone is facing an issue, then please let me know. Okay, Krishna, very good. This is correct. And Yusra, Rishan, and Hotvika, can you tell me the answer? Yusra, uh, Hotvika, C, and D. Yusra, very good. Hotvika and Rishan, do you get the answer? And if anyone have a doubt, then please tell me. Hotvika and Rishan, please share your answer. Okay. Till the time I am writing a next question, give me the answer, or if you have any doubt, then please let me know. Okay, Hotvika, very good. So Rishan, if you have any doubt, then please let me know, okay? After this, please start this question. Is no head appear? B, exactly one head appear. C is at least two head appear. At least two head appears. Okay. Please find out this to the form. To the form a set of to the form a set of mutually exclusive mutually exclusive and exhaustive event and exhaustive events. Okay. Please try this and share your answer. Okay, so you need to check both mutually exclusive and exhaustive. So that means nothing should be common and the union should give you the complete sample space. So first of all, please write the complete sample space. It should have 8 elements, then find them. Okay, Yusra, very good. Okay, Krishna, very good. Both you can, Rishan, please complete it and share your answer. Okay, Rishan and Hotvika, please complete this till the time I'm writing the next question. Udvika and Ishan, please share your answer. And please start this question and one by one share your answer. It is better if you first of all find the complete sample space. You will find the events, then it will be convenient to you to solve all the parts. Please try this question and share your answer one by one. There's no need to wait for the complete answers. Okay, Krishna, you are getting 1 1, 1 2, 1 3, 1 4, up to 1 6. Very good. Then 3. Very good. Then 5. Okay. Very good. Krishna, this is correct. Okay, so Hudvika, can you tell me the answer one by one? Please tell me the first answer. Okay, previous one.
So can we write it in that format what I have sent you, sir? In the
Yes,
note.
no. If as the outcomes are uh, as the outcomes are less, so it is better if you will write the complete answer. Okay.
Okay, sir.
Okay, Hotvika, please complete this and share your answer. Yeah, Yusra, sorry, that is A dash and not A. But Yusra, this is not B, not A. Yeah, A dash and not A is the same thing. Anyone have a doubt, then please let me know, okay? Hey, Krishna, you get the answer. Just give me a minute. Not B is 2 comma, not B is 1 comma 1. Okay. Not getting an odd number on the first try. Okay. So please find not B. Okay, Krishna, no worries. Not B is what? Getting on number on the first try, yes. Then not B means even number on the first try. Okay. Not B. You need to find not B. So B was getting an odd number on the first try. So not B means even number on the first try. Okay. So please complete this and share your answer. A or B. Yeah, A or B means getting an even number on the first try, getting an odd number on the second try. Okay, you're finding A or B. So just find A, find B, and write all the terms which are common to both A and B, and then write the remaining. That's the best method. Okay, so this question will take a lot of time. As okay, Krishna, just give me a minute. Okay, so that is 1, 1 up to 6, 6. Okay, Krishna, very good. Okay, this is correct. So this question will take a lot of time. So this is your homework. Please complete this. Krishna, 4th is correct. Complete this. And if you have any doubt, then we will discuss tomorrow. Your homework is exercise 16.2. Okay, and this question is from NCERT. This is question number 6. So you can find out the answer over there. Please complete this exercise 16.2, and tomorrow we will discuss your doubts and start the new topic. Okay.
Okay, sir.
Okay.
Thank you, sir.
Okay, you're welcome.
Thank you, sir.
You're welcome.